I'm going to give a pretty broad overview of depth sensing. What are the techniques? How do they work on a high level? What are the trade-offs and what are they good for? So I'll go ahead and advance here. So yeah, we'll start out with understanding what your depth sensing application needs, and then go through a lot of different techniques and compare them. We'll get to LiDAR near the end. So I'll jump into application needs. So you want to sense the depth of different objects with a sensing system. This could be, for instance, on a vehicle, looking at obstacles that you want to avoid hitting with that vehicle. So parameters you want to be interested in are what range do you want to be sensing at, both the minimum and maximum range your system can sense. And then what resolution do you want to have on that range? How close can two objects be in range without being confused as a single object? So you can talk about that as your Z resolution or range resolution. And then we have your transverse or angular resolution. So in the direction perpendicular to the range axis, how close can two objects be before you can't tell them apart? You also want to think about the reflectance of these objects if you're using light to detect them. What is the darkest object you might have versus the brightest object you might have in your application? And then you want to think about the constraints on your detection system, which should be cost, volume, weight, power, compute cost, all the usual constraints. Some additional considerations, do you want to have 2D depth sensing? Here we differ a little from the radar talk that was just given, and don't go into 4D, but 2D we define here as range and angle. So this would be, for instance, for a robot vacuum cleaner trying to avoid obstacles very close to the floor, but not caring as much about high up obstacles. Or do you need 3D, where you need to worry about both the horizontal angle and vertical angle? For instance, a drone flying around trying to navigate with a depth sensor.